Welcome back to your Level 6 Math. Today we are going to look at our Saxon Math lesson number 40, which we'll do some review with using 0 as a placeholder. We've already been doing that, at least I've been telling you to on the videos, but we haven't been very explicit about it with our Saxon Math. Then we're also going to introduce circle graphs today, or pie charts, pie graphs, so we're going to get into that as well. When we subtract, multiply, divide, we often encounter empty decimal places, like 0.5 minus 0.32. If we want to line those up, we add a 0 there. So I've been having you do that. But those are just empty spaces, right? And we can see as we line up decimal places, often there's blank spaces there. You can always fill those blanks with zeros. So if we want to subtract 0.32 from 0.5, we line up our decimals first. It's so important to line up those decimals. And then with the blank space, we can put a 0 in there, because if we're subtracting, we need to subtract it from something. So we're going to do subtraction. 50 minus 32 is 18, and so we just go over, we keep those decimals lined up, and we have 0.18. How can we check subtraction? Of course, the opposite, or the inverse, which is addition. Okay. All right, so if we're subtracting 0.4 from 3, I can't tell you how many students miss this problem. This isn't hard, but students forget to line up their decimals, or they ignore decimals. You can't do that. So if there's a blank space, you have to fill it. You have to keep those decimals lined up. So 3 subtract 0.4 would be 3.0 subtract 0.4, because you can't go like this, 3 minus 0.4. It doesn't work, because the decimal on 3 would be over here, so the decimals aren't lined up. You have to make sure those decimals are lined up, or you're going to get the wrong answer. So when you do that, 30 subtract 4 is 26, so we know the answer is going to be 2.6. When multiplying decimal numbers, we may need to insert one or more zeros between the multiplication answer and the decimal point. Let me show you what that looks like. So here we have 0.2 and 0.3. Remember, we've practiced this in the past, that if we have decimal points, we can just count those up and add it to the end. So one decimal point, that's going to be total of 2. So 2 times 3 is 6. And if we have 6, and we have to move over 2 decimal points, we don't move over 1, 2. So we're going to put the decimal there. Well, there's a space in the middle there, so you have to fill that with a 0. So the answer is going to be 0.06, not 0.6, not 6.0. We have to line up those decimals. So they're going to do 0.2 times 0.3, and same thing, you're going to move over 2 spots, and then we'll give you 0.06. Why must the product of 2.2 or 2 tenths and 3 tenths have 2 decimal places? Because tenths times tenths equals hundredths, right? Tenths times tenths equals hundredths, so there's going to be 2 decimal places. Use digits to write the decimal number 12 thousandths. So thousandths is going to have 0, 0, it's going to be 3 digits. So if we think 12 to fill 3 spaces, we're going to have a 0 first. So the word thousandths tells us there's 3 places to the right of the decimal. If there's a 12 in the last 2, there's got to be a space in between those, so you have to fill that with a 0. 12 thousandths, 0.012. Circle graphs. All right, so now we're moving over into pie charts or pie graphs. We use this a lot when we analyze data. So if you're a scientist or an accountant, actually most jobs, you'll do some sort of pie chart at some point. So it helps you display quantitative information, which is numerical information, as opposed to qualitative, and we'll get into that in the future, which is something completely separate. All right, so let's stick to the quantitative data. Here we've got a bunch of animals. Brett collected this from their classmates about their pets. So we display this in a circle graph. We've got 4 fish, 4 birds, 8 cats, 16 dogs. Now the reason they arranged it this way is if we add up the total, 16 plus 8 plus 4 plus 4, that's 32. And so we could say, well, what's half of 32? 16. So that's why they designed it this way. What's half of 16? 8. What's half of 8? 4. And so that's how they decided how big to make each section of the pie. How many pets are represented? We already added those up. There's 32. What fraction of the pets are birds? So there's 4 birds out of a total of 32. Remember our ratio, so it'd be 4 over 32, which reduces to 1/8. And then what percent of the pets are dogs? 16 out of 32, so 16 over 32. Greatest common factor there would be 16. And so 16 divided by 16 is 1, 32 divided by 16 is 2. That gives us 1/2. So total number 32, total birds is 1/8, and total number of dogs is 1/2, or 50%. All right, here is this is not a circle graph, this is a bar chart. So if we're looking at the support of a local bond measure for the November ballot, display the data shown below with the circle graph. So instead of 1/3 represented this way and 2/3 this way, we can put it in a circle. 1/3 plus 2/3 equals 1, so we can fill in that pie. 1/3 of the voters oppose the measure and 2/3 are in favor, so we just take 1/3 of this and fill that in, 33 1/3. 2/3 or 66 2/3 opposed, so we can just draw it that way, and we'll practice doing that. This helps us visualize the quantities relative to each other. And that's it. So good luck. Have fun with this.